So the first question they always ask is who is presenting to you? So honestly, my name is Egabo Aaron. Currently I'm doing a Bachelor of Science in Software Engineering, but I have some expertise within the tech space. So this is me. I'm a software engineer, more of a tech educator, and I love Web3. I deal in probably Binance and MetaMask. I have some few accounts there, and as well deal in Ethereum and USDTs. So basically that's it. I'm also a very active contributor on GitHub. Currently, I think I'm ranked like the 83rd, if I'm not mistaken, in the Ugandan GitHub community. So if I'm to look around here, I don't know that everyone is seeing my screen. Yeah, so currently in the Ugandan tech space of GitHub, I'm like the 81st, which is not bad, but that's what I kind of do. So this is my GitHub. For those who might not know, this is what I do, and these are some of my repos. I hope I'm not driving people very fast because I just want you to get to know whom you're talking to. So besides my GitHub presence, I have also some other presence of mine within LinkedIn. If you so wish to connect with me. So this is my LinkedIn account. That's why I post more of tech stuff, community outreach, and all that. So that's where we can connect from. So now with that said, probably I would give some space to allow some of my colleagues to share their insights such that we get into the session. I believe that's a great idea.
Right. Thank you so much, Aaron. Good morning to all of you. As Aaron shared, I want you to probably put an emoji if you can listen to me or get whatever I'm saying. All right. Well, I'm not going to share much as Aaron has done to save up time, but I am Rothomeo Evans, and I'm also pursuing a bachelor's in software engineering, although I'm a software engineer as well. So similar to him, I have some expertise in the tech field, and I'll be engaging with you a lot. But basically today, it's Aaron's podium. So thank you. Willing to engage more, learn from you, and also share the knowledge I have. Thank you.
Good morning.
All right, Martha, it's okay. You can say a word or two.
Good morning, everyone. I am Natozo Martha. I'm a software engineer. I'm part of the Women in Blockchain Africa. I love blockchain Web3. And I'm an active contributor on GitHub. I've worked on different projects. It will be nice to engage with you today.
All right, I hope you heard from all the colleagues you're going to be working with for today. I believe there's some other trainers around. I see Amokun Joseph, Pontifa Wencha, and the rest. So let's get straight to it, the initiation phase, where we take you through version control and the rest. So I hope everyone can clearly see my screen. I just need some feedback, like some voice from someone to tell me that they're actually seeing my screen.
Yes, I can.
Yeah, all right. In case of any queries, feel free to raise your hand or a hand emoji. Anyone within the trainers will be willing to answer the questions. So to begin this is more of an initiation into version control, and it's being presented to you by me, Egabo Aaron, working at Achilles Acacia. So now the big question that people always ask themselves is, what is version control? What is version control? But before we get to that, this is what you're going to be taken through. As I said initially, this is not a lecture, but this is what you're going to be asked within the industry, maybe through interviews, or maybe in the work you're doing within the tech space, or not even within the tech space. Trust me, it's going to apply somewhere. So this is what you should expect within this tutorship session. You're going to have a brief introduction to version control. We shall talk about that. We shall have a difference between Git and GitHub. You get to know what Git is, what GitHub is, and where they are used exactly. After that, you'll be taken through the installation of Git and all that. From the installation of Git, there will be the configuration of your Git identity. Yeah, right now those terms might sound kind of heavy or technical, but trust me, by the end of this session, you'll get to know them in their simplest version. Moving forward, you'll be able to set up your own GitHub account. I know some of you might be having already, but as I said, this is an initiation session by Achilles Acacia. So you'll be setting up your GitHub account fresh. So after setting up your GitHub account, you shall connect Git to GitHub to be more of a simple authentication. I'll take you through the steps, something very easy. From there, we shall actually test that connection live, such that you know whether you've actually connected Git to GitHub. Then at the end of the day, so in the session, we shall do some few commands, more of committing changes to GitHub. Yeah, so I hope this is what everyone else expected within the session. Yeah, so let's get straight to it. So the question I asked first was, what is version control? A lot of people hear what is version control, they hear a lot of versioning, all that, but they don't get to know what it is. Now, version control is more of a system that records changes to your file or a set of files over time, so that you can record specific versions later. Now, take this example. I know you've ever saved a document, probably project V1, project V2, maybe a final project V3, like within your local machine or your computer, right? Now, trust me, at this point, you were attempting version control manually. Like, let's say you were trying to save a document for the first project, then you found out it was not making a lot of sense. You wanted to improve it better, you made for the second one, then the final one. So technically, that was version control. So now, in the formal perspective, version control automates the process cleanly, safely, and at a massive scale. Now, to understand how this works in the modern software world, we have to look at this in two deeply connected tools. We're going to go through Git and GitHub. So let's start with Git. So now the question is, what is Git? I could say Git is more of a local engine. So Git is like an open source version of a system software that runs locally on your computer's operating system. For example, if you're having Linux, probably Mac OS or Windows, yeah, it can run locally on your computer's operating system. Now, what does Git do? It tracks the history of your code files, takes snapshots. In most cases, they call them commits of your project, whenever you tell it to. So it's more of a tool whereby you tell it to do some stuff and it does them for you, as explained above. Now, what is the benefit of using Git right now? For example, if you're to write bad code, for example, writing bad code of, if write bad code and completely breaks the application, for example, like at 2 a.m. Now, because you're having Git installed on your local machine, it can allow you to instantly roll back those changes. Here they call it like time traveling. You can roll back those changes to probably around 10 p.m. when the code was working perfectly. And how does this help you? It prevents losing any of your work and helps you progress further within your project. So that is more of Git. Next is GitHub. I hope I'm not moving very fast. I hope everyone is getting what I'm saying. Yep. So next is GitHub. Now, GitHub in this perspective is more of a cloud platform. Yep. GitHub is a cloud-based hosting service for Git repositories. Now, Git repositories in normal sense, let me say it's more of like a container where you're going to store files, store code or changes of anything made. So it's more of a container. But now these Git repositories, let's say they are within the cloud stored in GitHub. So GitHub itself is a company and it's also a web platform. And it's not a piece of software that's just installed in a machine. So what does GitHub do? GitHub acts as a remote storage hub, more of a repo, where you can upload copies of your local Git projects. So what is the benefit of using GitHub? GitHub provides a graphical interface, project management boards, and collaboration features. It allows multiple developers from anywhere in the world to download the same code, work on different features simultaneously, and match their work back together cleanly. So if I can show you like what I'm trying to talk about on GitHub, try to look at this, all these features within GitHub. Let me try one of these repos such that you see what I'm talking about. So as I'd said, within GitHub, there you can raise issues in case you find stuff wrong with code. There's discussion forum in case you're talking with other collaborators within that project. Git actions, just not that very many features within GitHub. That's why it's the enterprise tool used. Now, besides GitHub, there are some other platforms that are being used. Yep, some other platforms which are being used to store those changes. Other than GitHub, you might hear of GitLab. Yeah, GitLab also exists. There is also Bitbucket, if you've heard of it. Bitbucket of recent, a friend of mine, yeah, Ashley Cole, he got some project from some person. It was more of a 3D chess game, but the person wanted when players are having to play those with the automated chessboard, it's more of having them as artifacts. There's something of NFTs in blockchain, non-fungible tokens. So assuming those chess pieces, sorry, the queen, the rook, all that were more of artifacts and people play with them. And once you win the game, there's something of that you earn within there. So there's more of smart contracts involved, all that. So the person's project was being done within Bitbucket. So that's when I got to know about Bitbucket. So besides Bitbucket, there is also Azure, DevOps, there is SourceHeart, there is CodeBug. So all those are other alternatives to GitHub, and they do similar functionalities. But currently today, the biggest competitor of GitHub is GitLab, and they do similar purposes. So yeah. So now we've talked about what Git is and what GitHub is. But now these are two tools and they constitute one system. So this is more of a detailed side-to-side description of what Git is and what GitHub is. So yeah, Git is more of installed locally. GitHub is hosted in the cloud. If you look at the release date of Git, it was around 2005, while GitHub came closer to around 2008. If you look at Git, it's majorly maintained by the Linux Foundation. Yep. I don't know whether Linus Torvalds, the guy who created Linux, is still like the lead of the Linux Foundation. But yeah, what I know about Git is being maintained by the Linux Foundation. Then GitHub was purchased by Microsoft just of recent in around 2018, and it's being managed by Microsoft. Next, Git is majorly focused on version control and code sharing, like I talked about earlier, and we shall get to know more about it within the session. GitHub is majorly focused on centralized source code hosting, as I also talked about. Next, Git is primarily a command line tool. You'll get to know about it. It's majorly initiated via terminal. That. Next, GitHub is administered through the web. As I talked about earlier on, it's a web-based platform. All those things are orchestrated through the web. Moving forward, Git provides a desktop interface named Git GUI. Yeah, you'll get to know that forward. Then GitHub, there's a desktop interface, probably GitHub desktop. So that's basically about Git and GitHub. There are other significant comparisons, but you'll get to know them moving forward. So off to the next slide. I tried to get out some key advantages of why we need Git and GitHub version control. So these are some of the key advantages, because I know with systems like this, there are always advantages, and at points there are always disadvantages. But the disadvantages, right now, I'm not going to talk about them because that would be probably your research. But my major aim today is about version control and its advantages. So we can start with branching, or the risk-free experimentation. Now let's look at this scenario. You want to work on a project. Okay, let's say your project is already in production phase, right? Now someone tasks you to add in a feature to that running website. Let me say they want to integrate mobile money payments within your system, which was not initially there. Now what you will do, because you're having GitHub, you'll create another branch, right? Another branch within your project other than the main branch. So after creating another branch, probably it would be like a test branch, then you'll try and test out the integration of the mobile money payments, assuming it is to fail whatsoever. It won't interfere with the production ready code, right? You'll just simply delete it in case it's over disturbing, and it won't affect your production code at any point. So that's the importance of Git and GitHub branching. That's one of the key advantages. Then next is seamless collaboration. Now, look at developers today. Instead of you just sending zip files of code back and forth between developers and you frame it as collaboration, now there's GitHub, which allows collaboration between different users. Let me try showing you an example here of collaborations. Now, if you to look at this, this is a project I worked on with around 15 other guys. So if you to look at these are more of the contributors. So this is me. This was Mwawia. Yeah, this is Evans, the one who's around. Ashley Cole, Martha, and many others who are more of 15 working on this project. So that was for seamless collaboration. Now from there, I was more of the lead contributor, the lead maintainer, or should I say. So most of those people, when they were done with making features within that platform, they would initiate pull requests, right? And ask me, the lead maintainer, who would validate their code before merging it to the main branch. And at the end of the day, we came up with a very good project. Though we haven't yet scaled it, it's just there. So it enabled us to have a collaboration within what? Enables us to have collaboration within the platform. And lastly, about the key advantages, we're having the ultimate backup. Now let's look at this example. Your laptops are never safe, obviously. There are different bugs which affect all that. Now, assuming one day your laptop suddenly crashes or gets corrupted, gets lost, or even someone steals it. Now, that is something which is detrimental to you as a person. Now, you'd realize that all your entire history of projects you had, if they weren't committed to GitHub, they'll be lost just in the blink of an eye. Now, that's why we're having GitHub in existence, right? You keep on committing all those changes, pushing all your projects to cloud within GitHub. And in case any of those things happen, you can just get probably another device or a PC and just pull all those changes back to your local machine, and you'll be ready to go and proceed further with your projects. So that is about the advantages of Git and GitHub. So I hope everyone is trying to get what I'm trying to drive at. Any hand emojis, any likes? Yeah, all right. Moving forward, now let's get into the actual technicalities. Git installation. Yeah, with Git installation. So I'm just going to do a brief overview of how we're going to do the Git installation. It's going to be something quite tasking, but not hard to deal with. So with the internees, I don't know if you're all there. If you're with your PC right now, try to follow the steps, because I'm not going to repeat most of them because it's going to take a lot of time, because right now we're on time and people have a lot to do. But let me just get straight to the point and take you through the Git installation. Now, this is one thing I want you to all do before you installing Git onto your local machine. There are key things you have to take into perspective. Git cannot just run on any computer the way it is. You first have to identify the system architecture type of your PC. So the things that you can do are go to settings. Yeah, you can go to settings. I think I should just try showing live. Will be far better. So here you can try go into settings. I hope everyone is seeing my screen. Yeah, you can go to settings, then on system, you scroll to the extreme end where there's about. Yeah. So from there, you'll be able to know that your system type is a x64 based processor. So in this case, we're going to have two types. There is the ARM based processor and the x64. There's someone talking in the background. I don't know who that is. Okay, let me continue. So as I'd said earlier on, before installing Git on your system, you have to know the system architecture type. Now, based on what I showed to you, my PC is a x64 based processor. So before installing that, you need to check out that, because when I'm going to install it, those are some of the things you need to know. So if it's to deal with the x64 and the ARM64 architecture, this is a brief overview of what they each do and what each comprises of. Now, the x64 based microprocessor deals with majorly silicon wafers of Intel Core i3, i5, i7, i9, and the AMD Ryzen series. You can get to know all that, but just identify your system architecture type from the stuff I showed you earlier on. Now, the x64 is more of a traditional desktop and laptops like Dell's XPS, the ThinkPads, the HP Spectras, and the Dell Precisions, like the one I'm using currently. And they're majorly known for raw processor powers, high energy usages, and all that. Now, moving forward to the ARM64s, it's majorly in MacBooks, the ones you've heard of, M1 chips, M2, M3, M4s, the Qualcomm Snapdragon X's. I think you've all heard of that. What they're known for, they are powerful, efficient, fanless designs, and long battery life. For those who have them, you know what I'm talking about. Yeah, so for those who didn't see what I was talking about initially, this is the system architecture type I want you to all look at. Right. Make sure you identify this. So if yours is ARM, you will know, but mine is a x64. Now, after knowing that, now let's go to the actual installation phase, Git within your machine. So there are two ways you can go to any of your search browsers, sorry, any of your browsers and go to the search engine. It could be Chrome, it could be Edge, it could be Brave, like what I use. So just type in the command Git. Yeah, just type in Git, or you can just type in or you can just type in this link. Let me share it right now. Yep, there is that link. You can either type in Git within the search engine of your selected browser, or you fill in this link within the browser itself. And the first link obviously is Git, and that is what you have to tap on. Yep, that's what you have to tap on. Yeah. So moving forward, this is what you'll be presented with when you go to the platform. You'll be showed Git, all about it, the tools, the installation phases, everything you will need to know. So currently, we're going to install it majorly for Windows. Sorry for those who are using Linux, Mac OS, so any other stuff, because today we're going to currently focus on Windows, but I'll just show you the installation phases for the rest. You're going to Windows, you can tap on, sorry, let me go back. Moving forward, you need to install for Windows. You can just tap on this. So you can install for Windows. There are different features. There's the standalone installers, whereby you're having for the Time64 setup and the ARM64 setup. That's why I asked you initially to check for your system architecture type to actually know which version to get for your PC. There's also for Mac OS. For those who are using MacBooks, there is an installation phase for you. You can check via the platform. Here you'll basically be tasked with installing a homebrew within your terminals, probably command prompt or PowerShell in your PCs. Then for those using Linux, whichever distro you're having, it could be Kali, Debian, Fedora, or Cinnamon, depending. There are different installation phases for anyone using a Linux distro, depending on what you have. It's all within this platform of Git. My major focus today is going to be on Windows, as I said earlier on, and we're going to focus on the standalone installer. We're going to focus on this, a standalone installer. All this. So I hope everyone else checked for his system architecture type, whether it's Time64 or the ARM64, such that you can get to the installation phase. Is everyone at par with where I am, or I'm going too fast? I need some feedback, like 1 or 2 voices, and I move forward. All right. I think I'm being gotten loud and clear, so I can get straight to the next point. So if you've reached this stage of getting the standalone installer and you know your system architecture type, so you can either click to download for this, the Time64 setup, or for the ARM setup, to take around a very short time to install. Once you're done installing, you go to the downloads folder within your PC and click to go to the installation phase. So this is what you'll be presented with as you're installing Git within your system. It will obviously show you all this information you have to read before you check. But trust me, I believe everyone doesn't read those terms and conditions. People just check and move forward. So let's just move forward. Just have to check if you want it within your desktop, like to appear as an icon within your desktop. You can check on this button but the rest you maintain it as defaults. But I prefer not to have it as a desktop icon because it's going to be more of a terminal. Yeah, so I don't want it to be like as a desktop icon. But if you so wish to, you can check that button if you want. Moving forward, they will also ask you to choose the default editor used for Git. So me, I selected VS Code, but it depends on which IDE you have. Now, IDE in this sense, I'm meaning the integrated development environment that has the editor and other features. So majorly I use VS Code for what I do, but in case you have any other IDE, probably Sublime Text, I don't know where it works, Atom, Cursor, Anti-Gravity, yeah, majorly that. You can also put it there, but as of now, let's keep it with VS Code. Moving forward, just keep on checking on the default settings, because these are the default settings you'll be presented with. Just click on next for all that, click on next. Next, trust me, all these are default settings, and when you're installing it, they will be already checked. So just move on to the next ones. All this is next, next. Yeah, all that is done. So yeah. So when you're done with all those default settings, you just click on install and it will be installed within your PC. Now you won't see a notification which tells you that it has been installed. Okay, it might be there or it might not, but there is a way to actually check whether it's within your PC, right? Now I'm going to have two procedures of checking how Git is actually installed on your PC. The first one is either by using PowerShell or by using command prompt. So if I can try to show you how it is. So you can go to your start menu and type in PowerShell. You open, so this is what you'll be presented with. Then you just type in this script git space, then double hyphen, then version. Click on enter. Now, if Git is not installed within your PC, you'll receive an error which probably says it's not recognized or something like that. But because I have it installed within my PC, this is what I'm getting. I hope everyone is seeing it. The version that I have is 2.52, but this is more of the outdated version because I got it some time back. But I believe if you're to get the current one, you'll get an updated version of it. Yep. So the second option would be probably from command prompt. So you can just type in the Windows key plus R, then you type in the command CMD, like the way it is here. Click on OK. Then it takes you straight to command prompt. You can also type in the same script, git space double hyphen and version. So it gives the same information, clarifying or validating that I actually have Git installed on my machine. So now, besides all that, because I talked about it being more of a validation check to actually find out whether you have Git installed within your PC. The second thing is it also shows you the version of Git that you have installed. Like I said earlier on, mine is outdated, 2.52. Yours would be the one up to date, but they all serve the same purpose. So I believe we're all at par with what I've said. In case of any difficulties, you tell me, but that is it as of now. So let's move forward with the presentation. Yep. So we dealt with this, we checked with the versions. Yeah, it was installed. We checked also it on our command prompt. It was okay. Now, as I'd said initially, if it's not installed within your machine, these are the messages it will show you. If it's on Windows, yeah, on Windows, this is what you'll get for Windows. Git is not recognized as an internal or external command. If it's on Mac OS, after running the same script, by the way, this is what you will get, command not found. And for Linux, depending on any distro you have, this is what you will get. Yeah, I hope I'm making some sense right now. Moving forward. So I think as of now, we are done with Git and all that. So now we're done with the Git installation as well. So probably we could check that. We went through the introduction to version control. I gave you a brief overview of Git and GitHub, and I believe everyone has installed or knows how to install Git on their machines as of now. So moving forward, let's talk about the configuration of your Git identity. This is going to be somehow difficult.
Hi, Aaron.
Oh, yes, sir.
Yeah, that's an amazing. You're doing a very good job, and I love the pace. You're not moving so fast, and also I believe people are following so well. So the session is going on well. I just wanted to mention one thing. I think every after certain parts of the session, you could ask some people who may be having questions. And I want to ask members to push their questions in the chats. We have other trainers who are also good in the same area who are on the call. They will respond to those questions. You can also raise up your hand after the session so that we don't distract the session. After, the trainer will ask whether you have any questions. That's what I wanted to mention. You can proceed. Thanks.
Yeah, all right. As you had, in case of any queries, you push all of them to the comment section. Other trainers who are very capable will get to answer you. But right now, let's proceed with what's going on right now. So the next phase is the configuration of your Git identity. This is kind of tasking, and I urge all of you to pay attention to what I'm going to do as of now. So talked about us installing Git, it's already there, but now you have to configure your Git identity. Now, initially I talked about us keeping track of the code or the files or anything that we are to do within our machines. So to have that connected between your local machine and probably your cloud-based platform like GitHub, you'll have to configure your Git identity. So before you start tracking your code, Git needs to know who you are and who exactly you say you are within the machine, such that all the work that you're committing, all the work that you're saving within GitHub is credited correctly. It's not given to some other person or some other alias of some other person, but it's credited straight to you, the person whose identity has been verified. So I want you to all move and run these few commands. Yeah, I don't know. Let me try sending all this to the chat section such that everyone else can run these commands within terminal. So let's see. So there are a few scripts I need people to run to configure your Git identity. So let me get a few of them. So the first one is to identify your name. Yeah, first one is to identify your name within Git. Right? Then the second script is to identify the email that you're going to be using to save all those changes. within Git itself. So I think everyone can see those two commands that I've just sent. So for the trainees, I would love you to open your terminal right now, because I believe you're having Git bash on your PCs. So if you'd so be kind to open Git bash on your PC, then run these two commands. So let me try that. Let's put it here. You can type in Git bash, open this. So you will be presented with a screen, something like this. So I need you to punch in these commands, right? The first one, which says git config. The first one which says git config, global user, then your name. Now put in that name which you plan to use when you are creating your GitHub account, right? Because realize you haven't created your GitHub account yet. So where there's your name, you're going to have to put in your name that you plan to use within GitHub. Then for the second script, you also punch in that email that you plan to use within GitHub. So those are for the two scripts. And once you're done putting in those two, you can verify whether your Git identity has been configured. So if you're to look at this, you can try running this third script, this other one here, the one that has git config space double hyphen global space double hyphen then list. This is to actually check your identity within Git, whether you're actually configured within Git. So you can see as of now, you can see as of now, my username is Gabo Aaron. The email I used, okay, this is kind of random because I did some other settings, but I used my actual email, but this got configured later. All the other things are just not necessary for you to know, but what you need to know is that your username is there and your email is actually there. After filling in those initial two scripts, then you fill in the third script, which is git space config space double hyphen global space double hyphen then list. It has to present you with something like this, but customized to the information you filled in. So that is with a configuration of your Git identity. Now, the question remains, what is the advantage of that configuration that we just did, right? What is the advantage of that? The first one would be probably consistency across projects. Now, let's look at this. It ensures that your name, your email, and your preferred text editor, probably VS Code. Evans, Evans has his hand raised up. Evans.
Yes, Aaron. Thanks for this. Yeah, you had spoken about them running some commands in Git bash, but I'm looking at some of them not having Git bash, so they could use other alternatives like PowerShell, command line prompt. Yeah, that is it.
Yeah, they probably would use that, but as of now, I wanted them to use Git, because we're trying to use Git and GitHub, but PowerShell and Terminal would also be good alternatives. Yeah, thank you. Evans, another submission?
It's okay. So
Yeah, all right. It's all right. Let me proceed further with the advantages of the Git configuration I talked about. Yeah, consistency is obviously the first things, because remember, with configuration of your Git identity, your name, your email, and your preferred text editor, preferably VS Code or any other that you're using, remain identical, whether you're working on your personal side project or maybe you're working with a company repository, all of those things will be maintained. That's more of consistency. Preventing accidental commits under anonymous names, right? So that's one of the first advantages of configuring your Git identity. The second one is efficiency. In brackets, let's term it as a time saving. Now, remember, if you've already configured your Git identity, you only have to introduce yourself to Git once per machine, right? Let's say currently you're using your Dell Precision and you have to configure it like once. You don't have to configure again. Maybe if you're to change your machine to like maybe a Lenovo ThinkPad or something different, but it's once per machine. And you don't have to waste time running configuration commands every single time you initiate a new repository. So that is with efficiency. Moving further, we're having a flexibility. Yeah, flexibility. Now, in case you want to use a different email address for a specific client or an open source project, and you don't want the other email that you had used, you can simply override those global settings or those configurations by applying another script. I don't know whether you will be able to see that, but it's let me try setting that script. I don't know whether I have it here. Yep. You'll try running this script within Git. It's git space config space double hyphen then local. So yeah, that script will help you override all the other global settings you had applied earlier on and probably change specified features that you want to change within your configuration. Lastly, if to add like probably one other advantage of the global configuration or the Git configuration could be having a cleaner project repositories, right? Now, because your user identity is safely stored in your computer's home directory, your actual project folders stay uncluttered. They don't require localized configuration files for you to track who you are. So in this sense, your project repositories are stored cleanly. So those are some of the advantages of configuration of your Git identity. Right, so we can move forward. Yeah, all this, I think I talked about this. Now let's move into the next session. Let's move into the next session where we're going to actually set up a GitHub account. So we're already done with initiation, that's Git installation and all that. So let's move to the next session, or the next session, which is setting up a GitHub account, which is that. Okay. So let's proceed with setting up your GitHub account. So we're going to do similar steps as to how we did when we were installing Git. So you go to your preferred browser, Edge, Chrome, Brave, depending, and within the search engine, type in GitHub. And the first link, which is sorry, first link, which is that, is what you should select. Yep. Or if you prefer using links themselves, you can just type in this other script. Let me try sending this script as well. Can send in this script. You can just fill in that and to direct you to this page or this. So basically you'll be showed with the platform of GitHub. And there are a few things that you'll have to do. So right now, as I said, we are going to just configure new GitHub accounts. It's more of showing you how it's done. So you're going to have to go to the sign up button, which is at the top, the top right corner. Yeah, sign up button. With the sign up button, you'll be taken to this sign up for GitHub. You can continue with Google or continue with your Apple ID if you so wish to, or you can fill in all this information based on what you have. But I prefer you either continue with Google or Apple. If you're to continue with Google, for example, let's say I'm using this email of mine, aaronegabo19@gmail.com. So by default, GitHub will render a username just that. So it gave me this username, aaronegabo19-coda, but you can change it depending on what you want, and to have to first verify whether it is taken or not. Then you'll be tasked with selecting your country or region. As of now, I believe we're in Uganda. You can select that. And if you want any email preferences, you can also check that checkbox there, and you proceed to creating your account. So that is it for creating your GitHub account. Yep. So once you're done creating your GitHub account, we shall now go to the next stage of connecting Git to GitHub, or I like to term it more of the simple authentication, which is this. So we're left with more of 3 steps to do before we get to, no, 2 steps before we get to actually committing changes to GitHub. Connecting Git to GitHub through that simple authentication. So this is another area where you have to pay keen attention to, because it's kind of tasking and it might take me some time as well. So in case of any other submission, if you're not at par with me, feel free to raise up your hand or something like that. But I believe everyone is up to par with me, so I can move forward with the next stage of connecting Git to GitHub. So whenever you're connecting any 2 stuff, probably in this case of connecting Git to GitHub, there are always security protocols that you often have to follow as you're setting up that connection. Now, when it comes to that, this is your security toolkit. There is something which you get to know as SSH, and there is something called GPG. Now, all those sound like very big terminologies, but at the end of this, you're going to understand them to depth and in the simplest way possible. If I may just start, SSH is more of a secure shell. Yeah, that is SSH in full, secure shell. Then GPG is the GNU privacy guard. Yeah, that is for starters. So let's move forward with what they actually do and how this security toolkit is going to help us to connect Git to GitHub. So I believe we're all at par up to now. Any hand emojis? People are hearing me? Yeah, all right. I think that silence speaks for itself. I think everyone is getting me loud and clear. So as I'd said initially, the security toolkit deals with 2 components. That's SSH and GPG. Now, if I'm to just give you like a brief overview of what each of them does, I might love to start with SSH, or the secure shell. Now, secure shell is more of a cryptographic network protocol used to securely connect to and control a remote computer or server over the internet. Now, essentially, it creates a secure encrypted tunnel between your local machine and a remote machine, allowing you to type in commands within your terminal. Now, doing all this makes you feel like as if you're sitting right in front of that remote computer. All of that is just because of the secure shell. Now, how does it work in a simple analogy? Now, imagine you're sending a letter containing highly sensitive passwords through regular mail, right? Now, anyone who intercepts it can read it. Now, this is an encrypted connection. Now, this is what was being used within the older telnet protocols. Someone who can just access that, can intercept all that and take all your credentials, which are highly sensitive. Now, this is where SSH comes in, the secure shell. Now, using SSH is like putting that letter inside an indestructible armored lockbox. Now, it's only your computer and that remote server that have the specific keys required to open that email that has probably those highly sensitive stuff. So the good part about it is that even if someone intercepts that data traveling across the internet, all they will see is something meaningless or something scrambled. I don't know, guys in cybersecurity will be like it's hashed or something like that. There's something relating to hashing there. You'll just see something scrambled. So that's the importance of SSH in this case. Now, the use cases with SSH, what we're going to use SSH for as of now is that connection of Git to GitHub. We're going to use it as an authentication for Git and GitHub. How? Instead of us typing the usernames, the passwords, yep, every single time we want to push or pull code, we shall just link the SSH key to our GitHub account. GitHub will recognize the machine automatically and securely authorize your access. Yeah, that is one of the use cases we're going to have with the SSH keys. Then, secondly, I think it would be, okay, others, which could be other use cases, which you might not use here. There is a remote server management. Software engineers or programmers right now, those ones who want to probably access cloud platforms, probably like Azure, probably like Huawei Cloud. Most of them log into their cloud servers with SSH keys or the protocol. Then next is probably through tunneling and port forwarding. Now, this is majorly done by like network engineers. For example, if you want to securely route your network traffic from your local machine to a remote network. Now, SSH in this sense will act like a lightweight secure VPN. So for network engineers, they know how they use this in tunneling and port forwarding. Then lastly, with the use cases, you might find a secure file transfer. If you look at an example of your email, probably that, okay, maybe that's a far-fetched example. Let's look at this. There's this protocol called secure file transfer protocol. It's built on top of that SSH protocol, the secure shell protocol. Now, what it does is it works hand in hand with another protocol called SCP. SCP in full is a secure copy. So it lets you securely move all the files you need to move from like one local machine to probably another remote server. So that's how they all work hand in hand. So that is for that secure shell. That's how we're going to make use of it right now. Then next is GPG, the GNU Privacy Guard. Now, if you look at GPG, it's more of a free open source cryptographic software. People use it to encrypt, decrypt, decrypt, sign data and communications. Now, remember SSH, right? SSH is primarily used to build a secure tunnel to log into remote machines. Now, GPG is focused on protecting the actual data itself, right? The GNU Privacy Guard is focused on protecting the actual data itself. The data could be probably files, emails, code commits, all that, and verifying exactly who created them. So that's the importance of GPG. Now, let me give you another simple example of how it works. GPG by default relies on there's something called the asymmetric cryptography. There are two things involved there. There is a public key and a private key. Now, the public key is freely distributed and you can use it to encrypt data, to verify digital signatures, but it's open. Anyone can access your public key. But now, your private key is kept secret only by you and is used to decrypt data or create digital signatures. Now, this is where the asymmetric cryptography comes in. Now, the data encrypted with your public key can only be decrypted by the corresponding private key, eliminating the need to share a secret key securely. Now, these are all security protocols, but I'm trying to explain them in the simplest way possible. So now, this is the analogy of GPG. Now, imagine you want to sign an official physical document, right? You're going to be tasked with using your unique handwriting signature, yeah? And people will look at your ID card and verify it is yours after you signing with your unique signature. Now, anyone else, now, if you're to look at a GNU privacy guard, the GPG, now your private key acts as your digital signature stamp, right? Which only you possess. Use it to sign a file or a Git commit. So that is in relation to like you signing with your unique signature. Now, anyone else with your public key, which is fully shared, can instantly verify that the signature is authentic and that data hasn't been tampered with since you signed it. So use cases, for example, of GPG, signing Git commits, you'll see a verified badge within GitHub or GitLab. Let me try showing you some within GitHub. But you can sign commits here for this project. I don't know whether it will show some verified. Probably not. Yeah. So some of these, if you can see all these, there is a verified badge, right? To actually show that these commits came from such and such a person and they are actually verified. So this is a stamp and this is within GitHub. I hope everyone is following with me. Yep. So moving forward, that's one of the first use cases of GPG. Then the second one could be like email encryption. You know how your email is end-to-end encrypted. It's only you and the recipient who can see and read those messages that you send. Then lastly, could be software package verification. Now with GPG, most people on Linux, with Linux distros and software developers, most of them use GPG keys to sign software downloads. Now, if you're having like cracked software, let's say you got it from file.z or you got it from let's say Pirate Naben, Pirate Bay, and maybe use the like BitTorrent or uTorrent to download those corrupted software. Now, those ones don't have verified package signatures, right? Because they are cracked. And usually when you run them, you have to remove some stuff like probably turning down your security protocols such that they can install. It's more like a malware. Your PC will think it's a malware, but essentially it's just corrupted software. It could even have malware in it. But yeah, that is more of it. Now, in a nutshell, SSH is more like your passport. It proves your identity to GitHub so you can push code to to the server without typing a password. That's why I termed it as like your passport. Now, GPG is more like the wax seal. It stamps the actual code changes inside your repository, proving to the world that you're the one who wrote those specific lines of code, like I'd showed you earlier on from here. this has been proved that these are the people who changed these specific lines of code within this work. For example, Muawiyah did this, Evans, he did that, Ashley, he did this. All this is verified. Yep. So I hope all that makes sense. So now that we have gotten to understand what security protocols we need before connecting Git to GitHub, let's get to the actual way of setting up those security protocols. Yep. So these are the 5 steps we're going to take when connecting Git to GitHub. So the question still remains, what are we trying to achieve besides security? Obviously, security is the first thing. Now, what we want to do is we want to use Git bash directly with that SSH key that I talked about earlier on, with a secure handshake. It's more of approving that this is this, and they're agreeing with each other. So we're going to combine that with an automatic HTTPS to SSH translation rule, so you can fully copy standard links from your browser. You'll get to know this further as we proceed with the session. So we can get straight to setting up these protocols. Sorry. Yep. So this is the workflow, the first step. So within Git bash, I probably want you to open Git bash and type in this stuff. I may not type in everything as it is, but probably within Git bash. Yep. I don't know if I can see this. There are scripts I'm going to send. So the first script is the workflow of what you're going to do. So you can fill in this first script. You have to open Git bash and run the generation command. You'll have to hit enter 3 times to accept all the default phrases. So if we're to try that out, let's get this. Let me get the scripts for you such that you can move forward. So within Git bash, you'll be presented with something like this. So you'll have to run this first script, because it's usually hard to copy and paste within Git bash. You'll preferably want to type in the script, or you click Shift Insert within Git bash. Sorry. Okay. As of now, I can't put that there, but if you're with your PC right now and you've opened Git bash, you can fill in that command. Let me try sending it to group chat. Let's see. All right, so this is the first script you have to fill in. You'll have to open Git bash and run this generation command. There's SSH, all this, and then your actual email that you had used initially when you were configuring your Git account. You will fill it inside these quotations. Just type it the way it is. Then onto the second phase. After doing what you had done initially within Git bash, they'll present you a public key. Yeah, within Git bash, you'll be presented with a public key, which you'll have to copy, right? Copy that and save it in your clipboard. Yep, that is your public key, and that's the one we're going to use to place as an SSH key within GitHub. That's your GitHub account. So you'll have to highlight and copy that entire output block, which starts with this SSH-ed25519. If you're following through that, I'm sure you've reached there. Then on step 3, we shall have to save the key to your GitHub account. So if I may show this, Let me go straight to home. Oh, Rachel, you've raised up your hand. Any query?
Yeah, I'm requesting. Hello?
Yeah, I'm getting you loud and clear.
On the first command you gave us, the SSA
Yeah.
-keygen, you said, what do we do with? Because when I entered, I pressed enter and I got a very long message. I don't know what is the next step to do with that long message.
No, the long message presents you with, because I told you initially, after clicking that script like 3 times, you'll be presented with a very long message. Now you'll have to copy that message starting from SSH moving forward, because that is your public key. Yeah? Copy that starting from SSH moving forward, and that will be your public key. Just copy it and save it like in maybe Notepad or somewhere else. I hope that answers your question. Rachel, does that answer your question?
Yes.
Yeah, all right. Yeah, it does. So moving forward, let me show you how we're going to do that. Because the next step was saving that key that you had saved. Rachel had asked earlier on. That key that you have to copy and save maybe on your clipboard or somewhere else. Now, go to GitHub. Yeah, go straight to GitHub, probably within your browser or something else. On this icon up there. Yep. Check on settings. Check on settings. Then on this taskbar on the side, I think it's the left side, there is the SSH and GPG keys. So you'll have to select on that. Yeah, selecting on that. Don't look at my authentication keys. I didn't want to show you that. So you'll click on this button of new SSH key. Yep. So on that, you'll have to fill in an appropriate title for your SSH key. And the key type right now, I told you want to have an authentication between Git and GitHub. So leave it as the authentication key. Then in this text area where there is key, paste the other public key that you got initially, which was generated. I hope everyone is there. You'll just have to paste it there. And then after you end by adding the SSH key. I hope everyone is with me up to there. Rachel, have you reached up to there?
No, not yet there.
You're still navigating GitHub.
I've copied and pasted the other long message. I've opened GitHub. Now I'm there.
Okay, I hope you're seeing what I'm showing you right now. You have to go up to the extreme top where your profile is. Yep. Then you'll select settings as they are showed here. Select settings. Yeah, you'll have to select settings there. Moving forward, you tap on SSH and GPG keys. Hope you've reached up to there. Is anyone stuck or we are still there? Okay, I think we can proceed further. So after going to SSH and GPG keys, you will come to this and you'll have to check this button which says new SSH keys. So when you're done with that, you follow the exact prompts, fill in an appropriate title for your SSH key, maintain the authentication type to authentication key. Then within this text area here, that's where you have to copy and paste that SSH key, which is the public, which is the key that you generated, and punch it there. So after doing all that, we shall have to secure the handshake. We shall have to verify that that secure connection works directly by running this other script. So let me send this script to group as of now. So let me send that script. Let's see. Just sent a script as of now. So you'll have to fill in that script within Git bash to verify the connection. I hope we're all up to there. So after running that script, you'll have to type in yes. It could be like Y stroke N, and you type in maybe Y or yes if prompted. Then you'll receive a success message which displays your username. Yeah, that is verifying that you've actually secured your connection between Git and GitHub. So one other script that we have to run is we have to automatically link the translation rule. Now, assuming you want to clone a repository, or you want to, majorly cloning a repository, most people usually go to GitHub, search about someone's work, go to the repo, then they get that link from the browser, and they go into Git bash and run a command, git clone. Then they paste that link. Now, what this rule does, it converts that link, which is in HTTP, to SSH, such that whatever you're cloning, and during that cloning process, all your information and data is secure. Yep. So after you the other message of success, I need you to also run this final script such that translation rule is set within your PC. So let me send that script as well. So I think everyone has reached that stage, or everyone is following up to that stage. So moving forward, since we have already done connecting Git to GitHub, the only way to actually know whether it is done is by testing that connection. So again, we're going to terminal and we're going to see what to do from here. So I believe we're left with a few things to do, because we're done with setting up the GitHub account, connecting Git to GitHub. Now, what we're going to do right now is testing that connection. Yep, we're going to test that connection, which is this. Then we shall end by committing some changes to GitHub. All right. So let's move to that phase. Now, to test whether you actually have that connection, this is what I want you to do. I hope everyone is hearing me loud and clear. Yeah, is everyone still following? Oh yeah, all right. Thanks, Joseph. So in order to test that connection, this is the first step that you need to do. I need to create an empty test repo on GitHub, right? Open your browser, go to your GitHub dashboard. Now click that. Using mine. So let's go to this. Yep. New repo. Delaying could be probably internet connection. Create an empty repo on GitHub. Now you'll have to open your browser, go to your GitHub dashboard. Now click that green new button and create a repository. Now I want you to name that repository connection test. There are other features that you'll have to check there, but I don't want you to add a README or a Git Noah via the browser. Just click on creating repository. Let me try that, whether it's going to work. All right, currently I'm experiencing some network issues. It's delaying, but I wanted to practically show you how to create a repo. If you are following, you can actually create the repo. So if you're within GitHub and you've checked all that, and now you're creating your new repo, I want you to name it as connection test. You leave everything exactly the way it is. Don't add a README, don't add a git ignore, just go to the next screen and create the repository. On that next, you will see a box containing your project web link at the very top at the very top of your browser. That shows your repo link. So I want you to go to that your browser and copy that repo link and keep it in your clipboard. We're going to make use. Now, this is what I want you to do within Git Bash. It's going to be something fast and simple. Open Git Bash within your machine and type in this command. There is a mkdir, then connection test. Now, mkdir means a make directory. You're trying to build a new folder for your project. So you'll with a connection, then you'll type in cd connection test to actually enter into that repo. So to actually enter into that folder called connection test. So cd means change directory. These are more of a used in lineup command in Linux, but because these are also script of now where we're going to start tracking whatever change we're going to make within the folder. And this .b main is we're creating a branch where we're going to track all these changes, and we're naming it as the main branch. Yep. So moving forward to the next step, I want us to create a simple text file which we're going to send over as a commit. Yep. So you'll type in this script echo, probably testing my secure SSH link translation, then test.txt. You would have created a simple text file within that folder. Then you'll move forward to saving your changes locally. There's this script of git add, which is one of the git commands. So you'll type in git add, then the name of the file that you want to change. So it will be git add, then text.txt, the way you had typed it earlier on the third step. Then your next phase will be git commit -m, then the message. The message should be punchy and explain what exactly you're doing. For example, in this case, we're testing the setup connection. So this should be like your message. Yep. So that is phase 2. So moving forward, next is you'll be presented with having to connect to a remote to your remote GitHub. Because remember, all these changes were being made on your local machine. Now want to connect it to your GitHub repo. So we're going to use another git command called git remote. So you'll have to type in this script. Let me try send to you guys. All right, I think I don't have it, but the script that you'll have to type is git remote, which is this. Git remote, then add origin. Then there's this link that you'll have to copy. Now this link is the other link that you had copied initially, the one that ends with a .git. There is https://github.com/ your username. I don't know what name you're using, but mine I think is a Gabotech. Then /connection test. That is the name of the repository that we created initially. Then it ends with .git. Yep. So from that, we move to the next where we shall run the final push test. Now this is the time to actually prove whether we can actually ship our files straight from our local machines to the remote server in GitHub. So we shall initiate another git command in git push -u origin main. This is to push it to the main branch within GitHub. Yep. So after that, I think what you'll do next is just going to, we'll just have to go to GitHub itself. Go to GitHub itself. I don't know if it's working now. Let me try checking just to give an example. Still delaying as of now, but it's okay. So if you were done with all the steps, right? If you were done with all the steps as mentioned initially, you'll have to move forward with checking whether your commits were actually made on GitHub. You will open your GitHub, tap on your repositories, then you go to connection test, which is one of your repositories. Yep. From there, you'll check on commits. You'll see commits which are there. And the commit message has to be this Let me show you this. The commit message has to be this testing setup connection, like the message you had set up here. Then you'll also see a new file labeled test.txt, which means actually the connection happened and Git is actually connected to GitHub and you're secured. So in case anyone has tried and it has worked, maybe you can send a feedback in the chat section. If it didn't work, you can tell me as well, but it has to work if you followed all the steps as I'd said. So moving forward is now to the last phase where I'm going to talk little about, not too much, about committing changes to GitHub via a given IDE. Depends on the IDE that you're using. I don't know which ones people use, but preferably we're going to use VS Code. I've used many IDEs before. There was one by JetBrains when I was doing some Python sometime. It was called PyCharm. There's currently there's Casa, Anti-Gravity, depending on what you're using, but our main focus is going to be on VS Code. Yeah, where we're going to do some committing of changes. So if you have VS Code installed within, try to open it and move forward. I hope everyone is hearing me loud and clear. Evans, Martha, any submissions you want to add? Okay, I think I'm more than clear to go. Okay, Martha says it's fine. So moving forward to the last step where we're going to have to commit actual changes to GitHub via the IDE we have chosen. Told in this case we're using VS Code. So we're going to do this by a 4-step workflow. Sorry. We're going to follow this. We're going to follow this using a 4-step workflow. So once your initial setup is done, like we're done initially, configuration of Git identities, connections, SSH setups, all that, now it all comes down to one thing, your daily routine for saving and uploading changes to GitHub. It will just be through these 4 steps. Now, as a developer, software engineer, or anyone who's going to collaborate on GitHub, you're going to use this loop hundreds, maybe even thousands of times, yeah, as you're making all those changes. It comprises of just few steps. Starts with initialization, maybe through that command of git init, but you don't have to do it every time. The staging area where you'll have to add any other changes that you've done within your project. Git add the file name or git add with a dot to get all those files there. Then moving forward to the local save. Now, that's where we're going to have a snapshot of what we're saving as a commit. So we shall initiate a message, git commit -m, then the message indicating what changes we're making exactly to the files. Then lastly is now pushing those changes to GitHub. Yep. Now that is what you call the cloud save. We'll initiate a git push since it already knows where you're pushing it to. Or if you want it to a specific branch, it'd be like git push origin main, or maybe any other branch that you could be having within your workflow. Then once all that is done, you just keep on doing that for all the projects you're doing. I would have showed you that, but my internet is playing. I'd really love to show you how to do that, but probably another time. But if you're so willing to, you can try it out. Maybe I'll just show you something, though it won't be able to be committed because of that. So what I would ask you to do is launch Git bash via your IDE terminal. For example, VS Code. Maybe I think I can show you that one. VS Code. Let me try getting like maybe one of the projects I was working on of recent. Let's see. This is different. This is JavaScript. Let me show you an actual something I was working on. So let's try to open a folder. All right, maybe this website. Let me get a better one. All right, this one makes more sense. Yeah, so I think I was kind of working on this some time back. So let's say these are your code files now. I'm having an index. Sorry. I don't know whether you can see what I'm sharing with you, but I hope you can. So you'll have your folder resume, because I was building a personal portfolio website where I could actually download my entire CV just via the website. And also, it's more of interactive. I would show you that, but my internet is kind of playing right now. So let's say I'm having this as my root file, index.html. So within that, there are very many changes I could make. I don't know. Let's say changing a few things here and there, but let me just show you how it would work. Yep. So there is this. You can click Ctrl J within VS Code to open the terminal section. Ctrl J, or you go at the very top and you toggle that panel up there to bring you this terminal down here. So there's problems, output, debug console, terminal, and ports. So you check on terminal. Now, since you already have Git installed, you check on this button and look for Git bash. Yep. So you've initiated Git bash within your IDE, and in this case, it's VS Code. So it's already within the stipulated folder that I want, and that is resume. It's in the drive D of my computer and the folder resume. So I can do any change there. So as I said initially, you can type in git init, probably to reinstall the existing Git repository. That's the Git within there. Right now, I don't have any changes to make. I could check maybe with Git status. Yeah, so my branch is up to date and there's nothing to commit. But in case you had anything else to commit, you would have a git, then add, then the name of the file that you want to add. Or if you're not sure, you just add a dot at the end and commit all the other changes which are there. So you click on enter. If there were any, it would have showed you some here, but mine is vague. So you'd continue with a git commit space m, then probably the message, you type it there. Updating, maybe updating resume, portfolio, something like that. So once you're done with that, now, okay, right now, it's not identifying who I am because I didn't set up these configurations initially. But if you had done, it would show you all the changes that you're going to commit, to show you all the files that are going to be committed. And all you'd need to do is type in git push, then click enter, and it enumerates all those and sends it straight to GitHub. Or if you have a specific branch, it would be like git push origin, then the name of the branch, but maybe main, who knows. Click on enter, then it uploads it straight to cloud. That's on GitHub. So that would be initiating git bash within terminal. Something not hard. Yep. So moving forward, I think everyone saw the steps I followed: git init, git add, git commit, and git push. Yep. So moving forward, these are some of the essential Git commands which you can have reference with. For example, if you're setting up your repo, you can start with git init, which is initializing a new repo, git clone plus the URL, which clones or downloads that repo onto your local machine. Then git config, this is for setting those identities that we talked about initially. Now, the daily cycle of every developer is to follow these others. the daily cycle. Whenever you're committing any changes, you always start with checking whether you're having anything to commit by having git status, then git add with the name of the file that you're going to upload, or the dot if you're not sure, and to stage all of those files and put it like in some sort of limbo before you commit them. And the next phase is having a snapshot of whatever you're going to commit as a message. Yep. Then others could be like sync and branch, could be more of pushing or pulling. You could push your changes, pull new changes to your repo. Git switch, if you want to change like from one branch to another. Let's say you're collaborating with others on GitHub and you want to change from the main branch to another branch where you're working from. You can use git switch. Git merge, for example, you're working with work from your local machine and you want to merge it with what is in GitHub. You can initiate git merge to combine the work. Then lastly, you're having the undo and the utility tools. There is for git log, which checks the history of your git's commits. There is git reset, --softhead1, which undoes a commit that you made. Yeah? Then lastly, there is git stash, which is more of temporary saving. So I have a cheat sheet of all these git commands with me, but I think I'll share them with Mr. Edison, and he will share them with you if he sees it fit. But as of now, I have a cheat sheet of all the essential git commands you need with their respective explanations. And as if it also comes to VS Code, and there's some extensions you also need within VS Code. I also have a cheat sheet for all those extensions you need as a software developer, as a programmer, or any other person that you need them. Yep. So I have a cheat sheet for both of them. And the last cheat sheet I have is for the functionalities of other other online hosting platforms other than GitHub, maybe GitLab. There is Bitbucket by Atlassian. I have all information about them in a cheat sheet. So I'll share them with Mr. Edison, and in case you need them, you'll contact him and you'll find the best way of how to send them to you. Yep. So before I conclude, I forgot to send you some links to videos that will explain to you more about SSH. So it's more of a 3-part video. Let me just try sending all those links here before I finish. So there are like 3 videos which talk about SSH and its functionalities. So feel free to go through them. They are open to everyone to view. That's the first one. Then this is the second one. And lastly, that is the third one. So with all that said, I think I've been loud, clear, audible. I think probably understandable. Yep. And I think that's it from me. That's the end for now. I hope everyone understood what I was saying or got a glimpse of what I was saying. And I believe at the end of this session, everyone has questions to ask, or they have something to say, or they've learned something new. I'd love to hear your feedback or any other stuff. And that's it for me for now. I know I've talked a lot and people got bored on the way, but that's the way to go. I needed to bring out all this information for you to know, because it's part of the tutorship. Yeah, and I love doing it. So that's it for me for now. In case any of my colleagues has anything to say or to add on, Evans, Martha, feel free. The podium is yours.
Good afternoon, everyone. I would like to thank Aaron for taking us through the whole Git and GitHub installation and all the other things. I have nothing to add because you said it all. Thank you so much for listening.
Ashley Cole, I think I see you in call with Anne. Yeah. Any other submissions you'd like to add, such that people understand better, or if you have anything else to say, please feel free to share as well.
Yeah, thank you for the presentation. I learned one command I didn't know existed, which was the git local, right? So you can do the I believe is this per project? Like if I'm in one project and I do git local, I can set up my git stuff separately for that specific project and then go to some other project, do another git local. If that's the case, then yeah, I didn't know you could do that. And so yeah, thanks for teaching me, which I guess is also a lesson to the mentees, which is there's just an infinite amount of commands. I think I don't even think we've covered like 1% of them. So there's always something new to learn. There's always something new to learn. And so yeah, thank you for that.
Hey, can you hear me?
Yeah, loud and clear.
Okay, thanks. It seems my mic was taken in your control, probably. So I had to improvise with a mobile. However, I was speaking before, but I noticed nobody can hear me. I would love to appreciate you. I'll tell you that I'm highly how do they say it? I'm amazed. You're a very, very great trainer, and you can be one of the best trainers I have ever seen. Like I mentioned before, when you were underway, you have control over your speaking, and you have control over when you're speaking about the different technical aspects, which is a skill that I think it's a skill that is not taught. You basically adapt or learn it along the way when you're mentoring. Maybe I need to challenge you much more, but I'm really amazed, and you've done a very great job. I doubt any lecturer would do this from your classes. The way you took the entire group from the beginning to the end, and the different phases, and how you proceeded practically and technically. Um, you just need to be hired. That's what I can say. But I really appreciate you for that, and all members that have managed to be part of the call right from the start. The team members of Aaron, Call is on the call, Martha is on the call, Evans was on the call or is still on the call, Joseph, and all the other people. I really appreciate you, and all the others that left, other trainers. Wencha is also on the call. I really appreciate you. We're going to have. I expect next week on Monday to have the next phase of the version control, and going deeper into the setting up of a project, going deeper into collaboration. What I would expect, or something you could try out, is you could set up a project with. You could set up a project with, say, Martha, Call, with Evans, and then you demonstrate a full industrial collaboration. For example, say if Martha was in South Africa, and for you, Aaron, you're in Uganda, and Ashley Cole is in Germany. How would you work on a project? So you would demonstrate that collaboration, and how you'd follow through in the different versions, and how you'd you'd approve the different versions that you've worked on from the different staging areas. So that will be super amazing. I will expect you to work on that so that next Monday we get the improved the part 2 of this series. Allow me mention that tomorrow we're going to have 2 sessions are going to be happening. We're going to be having a session by Joseph that will start at 11 a.m. So it's going to be running online. So we expect everybody to be available in web development. Some of the things will be repeated in version control and also Trello management software for projects will be spoken about deeper. So you do not want to risk and miss the session tomorrow. Still, the link was shared already. I will continue to share the link tomorrow so that you're able to join. And also the other session is going to be on mobile development, UI and UX. But the mobile, it's going to be flatter. This is going to be physical. It's not going to be online. But of course, in the coming weeks, we shall have that online. So you'll have it, but it's going to be physical at the hub tomorrow. So it will be led on by Arnold. He's very good at that. And then Wednesday, we're going to have 2 sessions. So the first session is going to be at 2 p.m. It's going to go for 1 hour. And sorry, I'm cutting it short. And even on the call here, it's going to be led on by Wencha. It's going to be on accounting and finance. It's going to be more of a highlight. Reason being, I miscalculated. We have Alex Snyder, who is joining us at 3 p.m. to take us deeper into scaling businesses from a professional perspective of people who already have ventures. And this is going to be very good for mentors, and it's going to be very good for interns and the entire community. Registrations are already happening. I shared the poster, I shared the registration links. Please register and help me share it out to your entire community so that Achilles Akesho gets known further in the community, and also Cavendish University, who is a collaborator as well, gets known further in the community. And the contributions we do in terms of community engagement and skilling in to reduce on the education inequality, we all need to come together and do that together. So that will be Wednesday. So that will be this week. And then the following week, I'll be sending the calendar, of course, before the end of the week for the following week so that all members can track which program, what time is it running, is it physical, is it online. But so far is a very, very good start. What I can promise, Aaron, you're going to have a very big gift from me at the end of internship. Plus, your entire team, having Martha and the rest, you'll have a very big gift. You've done well. Thank you, and have a blessed afternoon. We can catch up tomorrow at 11 a.m. Great, thank you. The interns, you can give your feedback in the WhatsApp group, how you felt about the sessions, any questions you may have. The trainer is in the group who will be able to respond. And you need to give him his flowers, you shouldn't be quiet. You need to let him know how he did and where he could improve. If you feel, if it's speed, was talking so fast, so technical, he may try your mother language. You never know. Have a good day. Bye.